The topic that I am trying to explain is the engineering knowledge required for product and process industrial engineering methods of production. Right? Now, what is industrial engineering? Right? This is a definition that I have given. Right? Industrial engineering is system efficiency engineering. It is very simple and it is easy to understand. Because systems have to be effective and efficient. This is a standard statement in all management books. Effectiveness is the output of the system should be acceptable to the customer. When customer accepts what we are doing, the system is effective. And efficiency is to do with the profit we are making. Customer is buying the product, he is happy that we got the product. He is happy to pay some price, so that price we are taking. At the price we are receiving, as a producer, we should make the profit. When we are doing the profit, we are efficient. The product is acceptable to the customer, we are effective. When we are making the profit, we are efficient. We are more efficient if we are making more profit. The price is same. How do I make more profit? By reducing my cost. So if my cost is less and less, I am more and more efficient. Right? So whoever is doing the business, he has to take care of two things. The product that I am creating should be acceptable to the customer, that is effectiveness. The process that I am doing should be efficient so that I make the profit. So industrial engineering is concerned with efficiency. How to make the product and processes efficient. Somebody else is concerned with designing a product and designing a process which will produce the product which will be acceptable to the customer. So there is an effectiveness dimension, there is an efficiency dimension, and industrial engineers are concerned with the efficiency. As operations managers, you are concerned with effectiveness as well as efficiency. You have to simultaneously take care of effectiveness and efficiency. You have to take care of the product quality and the product specification so that customer will accept the product you make. Same time, you should be profitable. Your operations or your production shop has to be profitable. So as operations manager, you are responsible for both. But if you are an industrial engineer in your organization, that industrial engineer is more focused on the efficiency. If you are a product designer in your organization, the product designer is first of all worried about the effectiveness. The product that is created has to be acceptable to the customer. He has to take it and give a price to you. So when you apply the system efficiency engineering, it is applied during design and operating stages. That means applied during product design and during the process. For both, one thing. Other part I am trying to say is, when you are designing the process, also you apply industrial engineering. When you are running the process, also you apply industrial engineering. Cost reduction, you try to do at the design stage itself. Then you try to do whenever it is possible. Whenever it is possible, we implement the cost reduction steps. Right? IISc is the global body of industrial engineering. It has given a definition. Right? In the definition, what it says, IE is considered design and improvement of systems. That is what we are saying here. That it is applied during design and operating stages. The operating stage improvement, design stage is this. Industrial engineering, by name itself, has a strong association with engineering. It is connected to engineering. It is also connected to management. Right? It can be served as a management subject. MBA students should study industrial engineering. And you are studying, it is very nice. LMS program as industrial engineering for many years, which is a very nice and appropriate thing. But fundamentally, we are saying IE was started in an engineering institution as it has closest with engineering. Industrial engineering program started in a Penn State College in America in 1908, which is an engineering college. Right? It is there. It is still there in that institute. Right? Pennsylvania State University. The program is still there. IE award of deep thinking ASME regarding cost reduction of engineering products. ASME is American Society of Mechanical Engineers. It was started in 1880. In the first annual conference itself, the president of ASME has clearly mentioned that as engineers, we have created so many different products which are useful to the public. We are creating more products also. Along with that, it is our duty to make the products cheaper. That means to make them available at lower prices to the public so that more and more people can utilize it. So he gave a call for the cost reduction efforts from engineers. F.W. Taylor first implemented a system for increasing productivity rationally based on productivity science in machine shop. So a brilliant man has come. He is an engineer, mechanical engineer, working in the machine shop. He joined this American Society of Mechanical Engineers somewhere, let us say 1883 1884. He is active in the organization. So he came with a paper in 1895 where he said, I am implementing a system which gives rapid increase in the productivity in the machine shop. And from that system, the whole idea of industrial engineering has come up. And who has taken that forward in 1908 at Penn State? It was given a concrete shape by starting of the industrial engineering program. Right. So the question now in this session, what we are talking of is what engineering knowledge is needed for implementing industrial engineering methods. This is the question. We are developing the answer from a famous person called Redesigns, who developed value analysis and engineering. The discipline and the subject he developed, the area he developed is called as value analysis and engineering. What is it? Basically, it is productivity, cost analysis and engineering applied to products. He titled it as value analysis, but basically it is the productivity analysis or cost analysis and engineering based on that analysis. So value analysis and engineering is basically that value is actually called as the cost value. It is actually the cost of the product. So you take the cost of the product, analyze it and do cost reduction. Right? That is what it is. So I propose in the industrial discipline that we should call it as product industrial engineering. This is the appropriate term for IE language and technology. IE technology must have a term like product industrial engineering, wherein the industrial engineers focus on the product and redesign the product for a lesser cost. Right? But you have to keep the quality same. There should not be any difference in the earlier quality and the redesigned quality. Quality was the same. But can we reduce the cost? That is the focus. So another method now is available called design for manufacturing and assembly. Right? It is also now is a part of the product industrial engineering. Very nicely, L.D. Miles in his book wrote a full chapter on what is knowledge required for doing value engineering. A similar chapter is not there in any industrial engineering book. But everyone says that. And he says, suppose heat transfer specialist is there, what knowledge he requires? He requires knowledge of materials, heat conductivity, and practical shapes and ideas for providing, preventing, or controlling the flow of heat. Right? Suppose I don't want heat from outside to come inside this room. What I should do? Different. If I want the lighting to come into this room, what I should do? Different. The designs are different. The heat transfer specialist should know that, right? One thing is to know material, which material should be used, right? To do heat transfer. to stop the heat transfer. Right? Cold, we put some woolen clothes. Right? We want to be hot inside. We don't want inside heat to go out. Right? Summer, we want very quickly the heat should go out. Right? There is a difference within itself, the requirement. Right? Such a specialization is possible and useful in mechanical engineering. There are other areas also. Myself, take this example. Right. In contrast, engineering knowledge required for value engineering is extremely broad. You cannot have a very narrow specialization of engineering for doing industry engineering or for doing value engineering. Right? Knowledge relevance specific to product design is not sufficient. Which is sufficient in mechanical design. Somebody can only design screws and he has spent his lifetime in design of these screws or bolts and nuts. His life is over. Not sure here. Value engineer has to deal with and explore a multitude of technologies and product areas to redesign the products assigned to him. So whatever product is given to him by the company, he has to do the value engineering of that particular product. So he has to know many more technologies and many more things. So what is the type of information required to value engineer? He requires information on the materials. He requires it on the processes. He requires what is called as a functional product. It's a standard part which is used for certain functions. And because it is a standard part, somebody said repetitive, because a large volume is being done, it comes at a cheaper rate. Right? So the value engineer should know what are the available functional parts so that he can buy them at a cheaper rate. Engineering approaches to get functional performances means we say the function required is fastening. Suppose we say the function required is fastening. Then we should know what type of design is there to get that fastening purpose. Or we say tightening. Or we say loosening. Right? So anytime you are telling a function, how to get that function from a part and function. Right? Practical economic function solutions in current use. Today, for a particular function, what is the solution? What is the function? I have to come from target to here. So, what is the most economical here? What is the most comfortable here? Right? But one time over is not there. Today over is there. So, it is more comfortable. Right? So, what exactly is available? Functional alternatives. So, what is the best value alternative? What is the best redesign? Which is the best value alternative? Is the best combination of materials, processes, and the related ideas. That in a combination give you the low value, low cost product. Right? The product has to have a low cost for which the engineer should know materials, processes, their ideas how to use them. Right? I know a material, but I don't know how to use them. Right? I have to know how to use that material to get the function that I want. So you naturally require a library. Right? A library of knowledge, media, like books, magazines, journals, information, the various catalogs and the manufacturers, consultants, business organizations, all this has to be available as a library to support the engineering department. Right? These days, not only library, we require the digital databases, the library is insufficient. Apart from that, what it says is, you must be able to have access to the knowledgeable people. You should know in a particular field who is a knowledgeable person and try to contact that knowledgeable person. I have to do this activity. Is there any information that you give which is going to help me? So, a well-architected resources of special skills needs to be maintained by the value. Not only the general knowledge, if certain special knowledge is there, you need to get that information, right? Address various consultants and institutions has to maintain with the value engineering department. So, what sort of knowledge is required? What sort of knowledge is required? Knowledge which enables you to say that this material can be used in this particular application. Feasibility. Second is, what is the likely cost of using that? Because what is your focus? Lower cost, lower cost. So, when I presently was spending 20,000 with some material, the alternate material should cost me 18,000 or 19,000. Then only it useful alternative to me. Right? So, the two directions in which I should be able to make a judgment. Is it technically feasible? Is it economically useful? This, what is the far component? Once again, the same idea of the handbooks, catalogs, etc. Then what he says is, what Aldi is trying to say is, you should be able to link the cost to the property, right? When the property means, suppose hardness of material is a property, which is desirable, right? So lower hardness, what is the cost? As increments of hardness are increasing, what is the cost? So don't tell me brands, materials cost. That is not useful to me. What you should tell me is, from starting to lower level, as hardness is increasing, how my cost is increasing. That is the property. So reach our depth of knowledge. Same point we are once again trying to say. Value engineers are going to less in number compared to performance engineers in the organization. Right? If I am talking product design, first of all the product has to work. So there are more engineers in product design who are focusing on how to make the product work. And value engineers are industry engineers going to be less. So because these are less, they should know more. They are more, each will know less. But values are less, so they have to know more. Therefore, they will work on variety of products and components. Therefore, the knowledge required is a extremely broad amount of knowledge is required. Also, interest and ability to learn the required engineering knowledge on a just-in-time basis. Right? Suddenly, a topic and we take the topic and some engineering knowledge required. So I, as an engineer, should be ready today to sit down and read for next 2 days and try to get that engineering knowledge. Right? So it is a continuous process for these value engineers, industry engineers, that they have to learn on a just-in-time basis. Only when you come to know that I need this knowledge, you have to go acquire that knowledge. Now, earlier what we were discussing, Redesigns, value engineering, which is product industry engineering. For process industry engineering also, we require a similar knowledge. Right? Whatever Redesigns said regarding product industry engineering, we have to know regarding the process industry engineering also. Right? In addition, we can say this sort of in this one. In case of manufacturing process industry engineering, we can identify that we have required knowledge of the basic production processes, casting, forging, basic machining process, turning, boring, milling. You keep on telling that it comes. So what are the machines and machine tools which are useful to do that basic production process? What are the cutting tools? What are the machining accessories? What are the machine consumables, cutting fluids, lubricants, etc. What is required to do the machine? Right? Then the cutting conditions come, right? Or in case of any machine, what enables me to run the machine at higher speed? What are the variables which are going to allow me to run the machine at higher speed? If I run at higher speed, quality may go down, right? So I should know what are the variables that affect the quality of the output. Because an industry engineer or a value engineer have to maintain the same quality. After redesign, the earlier quality should come. right? I reduce cost, quality should not go down. I increase speed, increase production, quality should not go down. So, if you are taking of industrial engineering students, right, what should be their engineering knowledge? How should you develop their engineering knowledge? That is the question. So, in ED, we run industrial engineering program and we take students of all branches. Any engineering student of any branch can join ED and do industrial engineering. So, what we should do? Number of IE programs admit undergraduates of various engineering disciplines. So, in the orientation itself, we should tell them, please refresh your undergraduate engineering knowledge. Without engineering knowledge, there is no industrial engineering. There is no product improvement, there is no process improvement without underlying engineering knowledge. Only your expertise in engineering knowledge will help you to improve the products and improve the processes to increase the productivity. Suppose there are programs where directly BTech industrial engineering is there, right? In such a case, in the first 2 years, you have to give the engineering inputs, right? Along with what is industrial engineering, you are explaining. Along with it, you have to give engineering inputs to them, right? And then that part we are trying to do it here. Students of IE are to be self-learners in engineering, right? So that they self-learn required engineering on a just-in-time basis. Only after I take up a product or after I take up a process, I come to know I require this engineering knowledge. So I should be able to take a handbook or an encyclopedia and start from that and do that, right? So this we are once again emphasizing this point. Process improvement or product improvement requires knowledge of engineering alternatives. Improvement comes through alternatives and knowledge of alternatives has to be there in the industrial engineering, right? So, before undertaking productivity analysis or value analysis, industrial engineers have to search and acquire engineering knowledge related to each element of the process of the product. So, when I come to know the existing process or existing product, I have to break that into elements. So I know what are all the elements which are present. And about each element, I require engineering knowledge. So I have to acquire that. I have written all processes, right? It is there. Now in each process, we identify some elements. Unless we get external knowledge regarding the elements, we cannot attempt any improvement. Process improvement can only be done when we are confident that we have knowledge of the elements, alternatives of the element. Right? So, today, as I said, I am distributing the internet the case studies. So, today's case study happens to be this. Right? Sometimes I have created this in the case of the milling machine. Right? What are the elements of the milling process? Right? And some information regarding the elements. Elements are material, right? Various machine tools in milling, various cutting tools in milling, various fixtures, various machine consumables, and then certain issue of the cutting conditions. Like that, each and every operation or element, industrial engineers have to collect information. Right? That only will enable us to do the process improvement. Right? Thank you.